Greetings everyone. I quickly want to go over a few important points concerning wall framing. Several pages of your design will include drawings of the inner workings of walls. First, let's go over a few key points. The framing portion of the wall is called the core because it is in the middle. The core is comprised of 2x4 lumber, or actual measurements 1.5 inch by 3.5 inch. And these timbers, or this wall, consist of a seal plate at the bottom. We have vertical studs that go from the bottom up to the top, and then we have the top plate, and then we have the double top plate. If your wall has doors and windows, such as this one, you'll have a header with cripples. You'll have trimmers that are supporting that header. And you will have king studs, which are on both sides of the doors and windows to add extra support for that structure. And then you have your regular studs. That's these right here in brown. And you also have a window sill right here. And that's about it. Notice the top plate is cut shorter. And there is a reason for that, which I will go over in just a moment. But anyway, of course, when you design your walls in your plans, they will not be colored this way. This is strictly for demonstration purposes. You'll actually color them just the way that you normally would. Now, once the wall is assembled on the job site, it will be erected and the sill plate will be bolted to the concrete slab. The vertical studs, as you see, these vertical studs are mounted at 16-inch and 24-inch centers. Sometimes the exterior and the load-bearing walls are mounted on 16-inch centers, while the interior partition walls, walls that do not have a structural purpose other than dividing a space in two, they're mounted at 24 inches on center. Wall studs for low-cost housing are sometimes mounted at 24 inches on center throughout. The main benefit of 24-inch centered wall stud mounting, besides cost, is that the walls gain a greater R value, or heat resistance value. Some homes are built using 2x6 lumber, or the actual measurement of those timbers would be 1.5 inches by 5.5 inches. But those studs are mounted at 24 inches on center to take advantage of the increase in R value while shoring up the sturdiness of the wall with the thicker lumber. For the top plates, notice in this picture here that there are two of them. The first is cut the same length as the bottom sill. However, the top plate is cut either 3.5 inches longer or shorter at each end to allow for tying into other walls. Typically, you will have walls that extend further than the length of 2x4s that are available. Generally, 2x4 lumber is found in 8, 10, and 12-foot lengths. When stringing walls together, make sure that the top plate overlaps the joining wall by 48 inches. And I'm sorry, I really don't know where that figure comes from. It's just the way I was taught to do it. And besides that, you probably would not even make that decision in the drafting phase anyway. That would probably be a decision, made could be made on site, or an engineer or someone of that nature who's looking at your drawings may make that decision and have you indicate those cuts. Anyway, the next slide is just a section, cross section of a wall. And it just shows you the different components. The core, and get used to that because that's what they refer to the center timbers of the wall, or sometimes it's even metal studs. But some of the software you're going to use refers to this as the core. And then the exterior, consisting of sheathing and wall covering, which is also considered above core. And then the interior drywall or paneling, which is the inside of the house, is also considered let's say below the core. That's what I was trying to get at. Now the next slide, of course, is some brief notes on all of the stuff that I just discussed for you to look back on and study. And that is it.